Benchmark. We need to know where to start. So I'm Jeff Brito.
I'm Mike Brecken.
And today we're going to continue our series by talking about how we measure heating systems or cooling systems against each other. Because when we're shopping for new equipment, we need some way to say which one's better or worth the money. And one of the few tools that we have to sort of level everything out is, in a general term, what we call efficiency. What is efficiency? Because you don't get the same numbers from every piece of equipment. And we also get different perspectives on what efficiency means. So, for example, one of the common questions I get when we talk about heat pumps in the market is a customer will say, well, but is it efficient? And what I think they're really trying to ask me is it dollar cost efficient to use it? Is it does it cost a lot of money to run is really what they're asking.
Because how much is it going to cost?
That's right. Because I usually respond with, well, they're fairly efficient, but they're not nearly as efficient as an electric baseboard, if that's what you're asking. An electric baseboard is 99.9% efficient.
Correct.
But it costs a lot to run it.
Yes.
So getting a grip on what we're talking about when we say efficient, and then taking the next step, well, once you get past efficiency, then you've got to talk about what the cost of operation is. And we'll get into that in another episode where we talk about different fuel sources and how to compare what a machine costs to run on different types of fuel. So I think first thing to start with is just a brief discussion of what efficiency means. So why don't you give us a brief rundown?
Well, the different pieces of equipment, there are yardsticks to compare them. For fossil fuel equipment, there's what they call annual fuel utilization efficiency, AFUE. So you can compare natural gas furnaces one to the other from about 78% up to, I think now they get to close to 98%. And if you're doing a air source heat pump, there's what they call HSPF, Heating Seasonal Performance Factor.
So what do all these numbers mean, though? So when we talk about efficiency and percentages versus, HSPF, what is it that these numbers actually mean? And if we go back to
the higher your number in HSPF,
mm-hmm.
the less electricity you will use to do the same job.
Right. So if we start with efficiency, because most people are more familiar with that number, it's a little easier for people to grab get their mind wrapped around. Efficiency is the amount of heat that you get out of an appliance for the amount of energy that you put into it.
Correct.
So, and that's a percentage. So we can all imagine that if you have a gallon of water, or let's go even further, say it's heating fuel, right? If we pour that gallon of heating fuel into this oil boiler behind us, how much of that gallon actually gets turned into useful heat in the house? And that's what the efficiency is. So this thing probably runs in the 80 to 85% range. So that means, 15% of the oil that you're putting into the machine actually goes up the chimney pipe or leaks into the basement. We can get
the heat from that oil goes up the flue.
The oil itself actually also goes up the chimney.
Yes.
It gets turned into other things,
right.
Carbon dioxide and other chemicals after it's been combusted. But the other part we're assuming goes into the building, and that's the 85% part. And we get into heat pumps, we get a whole other set of numbers. And why is that?
We get coefficient of performance.
So why do we have to have that different number?
Because we're using different fuels. We're using electricity.
Well, it gets a little more interesting than that. Webster's dictionary says efficiency, and if you look in your physics books, can never be greater than 1. So when we say, okay, let's take an air source heat pump, and on simple terms, they do publish COP numbers for them sometimes. So at 50 degrees, the COP may be 2.5. What does that number mean? Well, it turns out it's actually on the same exact scale as efficiency. So if we say a boiler might be at 85%, that means that less than one of the gallon that you put in actually gets turned into a heat.
Right.
Well, a heat pump doesn't suffer that problem. A heat pump can actually make more heat than the energy that you put into it because it's not burning fuel. So it actually performs such that it produces a greater than 100% efficiency. And since the dictionary says you can't call it efficiency if it's over 1, we had to make up a new term, and that's why we call it coefficient of performance. So it's actually on the same scale, and we'll draw a little picture here.
Which is the ratio of the heat output of the device versus the electrical energy you put in.
That's correct.
Converted to what they call BTUs.
That's right.
British thermal units.
Yep. Which is the same thing when you're down below 1. You could still call it COP. It would just be a fractional.
Right.
This would be a COP of 0.85. So that's where we get in, why we have these silly terms that we have to deal with that confuse everybody. so we get into COPs, and then you brought up a great one, HSPF. So why do we have 2 numbers for heat pumps? Well, the big thing is when you try and do a calculation just based on COP, the problem is COP changes with the weather.
Yes.
So with an air-sourced heat pump, and we'll get into details of what that means a bit later, but that means you have a piece of equipment outside in the weather that's trying to capture heat and bring it into the building. Well, its performance changes with the outside temperature. It's much more productive at higher temperatures than it is at lower temperatures, and that means its efficiency changes. It's less efficient when it's cold out than it is when it's warm out. So how do you
Plus,
how do you
when it's
compare a
colder
machine?
out, even though there's not a lot of moisture in the air, there's some.
Mm-hmm.
So you have to have that outdoor coil, cooler than the outdoor temperature for the heat to flow from the outside air to the coil. And if you get below the dew point, you will form frost.
That's right.
So the unit then will have to reverse itself and melt that frost. And that has to be factored in.
Right?
It's non-productive time.
So that also impacts the total efficiency.
Yeah.
So if you're trying to compare an appliance that runs without an impact of weather, like the boiler here, it doesn't much care what the outside temperature is unless you tell it. How do you compare that to a machine that has to deal with the outside weather? And that's why the government came up with these 2 different classes of measuring sticks. One is HSPF, which is a heating seasonal performance factor, and that tries to estimate these weather changes throughout the seasons, the things like the defrost capability. And the sister factor of that is for air conditioning side, they use a different term, unfortunately. So that's seasonal energy efficiency ratio. And it's trying to do the same thing. The hotter it gets outside, the hotter an air conditioner has to work. Or harder an air conditioner has to work. So we've got a term that tries to incorporate the seasonal impacts so that you can have a better measuring stick to compare the performance of one machine versus another. So an example, how would you do that? Because there aren't as many choices in air conditioning, right?
Right.
You've basically got packaged or unpackaged air conditioners that sit outside, or what else? You have water source, and not too many of those around. It's getting more popular, but geothermal is a great example of a water-sourced air conditioning system. It's not impacted by weather. It's the ground temperature that's fairly consistent all year round. So you typically don't see SEER ratings for geothermal equipment. It doesn't really work that way.
Right. You see energy efficiency ratio
Correct.
Numbers for that. And that changes a little bit based on the water temperature coming to the unit.
Right. And there can be some variations with geothermal equipment throughout the seasons. As it works more and more, it might warm up the ground or cool it down in the wintertime.
And there is a fancy formula that you can multiply your HSPF by a number that ASHRAE came up with as some sort of average, and it will spit out a SEER rating.
Yeah, and so these are all the little nuances that you get into, and you might need your comfort technician to help you walk through, because even we sometimes need to reference our paperwork. So certainly we can't remember all the numbers all the time.
Right. You can go on different websites, like Efficiency Maine has a website, and they have pellets, and they have cordwood, and they have natural gas, and they have lines that you plug in your cost of fuel, and then
fuels.
But what you can't figure out on their site is what the building needs for either heating. Well, it's just the heating one.
And I don't think they let you put in the efficiency either. They just give you a category.
No, if it's Energy Star,
right,
it's that.
But
so
Energy
you may
Star is
buy
a big window. So
yes.
you might have a really good Energy Star, and you might have a less than good. It's not that they're bad, because they're all Energy Star. But so what we were trying to get to is, all right, when we're looking at appliances and we see all these numbers, how do we compare them to each other? And my company website at Intelligent Heat and Power used to have a nice little calculator, but we've taken it down in our redo to make it mobile friendly, but hopefully that'll be going back up, and you'll be able to plug in, what your fuel cost is, and plug in what your appliance efficiency is, and it'll spit out a dollar per BTU number, which is handy, and we'll talk about that in detail when we get into the dollar per BTU fuel episode. But the long and short of it is we're looking for a way for us to make decisions when we're buying a new piece of equipment, a new system. Do I go with the HydroWare system? Do I pick a air source heat pump or a geothermal ground source heat pump? Which way do I go? Which one's gonna cost me more in the long run versus what's gonna cost me to install? And these are the measuring sticks we have. We have efficiency, and that comes in kind of two varieties. Your instantaneous efficiency, the thermal efficiency, is just what it's doing at any given instant. But the AFUE number, much like the HSPF and the SEER numbers, are trying to take into account some of those practical impacts. We've got the two efficiency numbers, AFUE and thermal efficiency. When you're shopping, AFUE is really going to be the only one that you see. And then we get into air source heat pumps. We've got, sometimes you see the COP number, but more easy to compare it with the HSPF number. Yeah, and then on the cooling side, we got our last couple of big brackets, and that's going to be the EER and the SEER, the energy efficiency ratio and the seasonal energy efficiency ratio. And those are our tools to be able to measure things back and forth. Now, that's not the end all be all. We'll probably do another episode not too long discussing the other impacts that you might want to consider when you're purchasing a heating system, because efficiency is just one piece of that number. The other comes into comfort. And one of the big topics that we talk about that is, particularly with air-based equipment, is when you have modulating output and what that does for how you feel.
Right.
We'll give you a little teaser. If anybody's familiar with having an old-fashioned forced air system, I hear a lot of complaints about hot, cold, and drafts, right? And when we get into modulating equipment, a lot of that goes away. So efficiency alone isn't the only answer. So let's wrap this episode up for now. And if you like what you see, please hit subscribe and take a look out for our next episodes coming up. And we'll see you then. Thanks.
Thank you.